Hey, what's up guys, my name is the Cherno. Welcome back to my game engine series. So, last time we took a look at the beginnings of the whole IMGUI docking situation, basically being able to have a docking layout for our window, and then that way we can drag panels around and we can dock them and do all that fun stuff. Check out that video if you haven't already. That was last week's episode. Today, we're going to continue on with that, but we have kind of the new problem that we got up to last time, which was how do we actually take our scene and the whole kind of scene rendering that we have going on and actually display that as part of a docking panel. And the answer to that is we basically need to render it to a texture, and then we can actually use that texture as part of IMGUI, something that we are hopefully going to do today. So let's jump into the code and take a look at how that's going to work. So basically today's episode is going to be all about frame buffers. If you don't know what frame buffers are, I don't think I actually have an OpenGL video on that. I should probably make more OpenGL videos. If you guys want to see that as part of the OpenGL series and you want more information on frame buffers in general from me, then let me know and I might, make an episode on that hopefully. But as it stands right now, I think that I'm missing a lot of things in that series, unfortunately. So that's the way it is. Let's fade to this. So you guys didn't really say anything. I don't know. I didn't see too much about the face cam. So if you like the face cam, if you want to keep the face cam, then let me know. If you want me to remove it, let me know, and I will do whatever you guys want, because I'm such a nice person that way, Also because I can't decide whether or not I like it. So let's not talk too much. Let's actually do some work, because my goal, as I mentioned last time we talked a lot about what we actually wanted to do with Hazel in general, and I think that a big thing that we wanted to do was, obviously the big thing that I kept talking about was that I want to get it to a state where you guys can actually make 2D games within the Hazel with no C++, no like maybe a little bit of scripting in terms of programming, but no like C++ programming or anything. You should just be able to construct it using the editor. So we obviously have a lot of work to do, and I'm going to stop talking about that. So this is what we did last time. We had this kind of image being displayed with IMGUI, and today what we're going to do is we're going to kind of build on that, and we're going to implement frame buffers. So what we need to do is this, and it obviously helps to define what it is you need to do before you start working on it. Let me just enable this. I added this. I didn't commit anything last time during the actual episode. I did that kind of stuff, just making sure that I'm recording. I did that kind of stuff afterwards when I actually stopped recording, and then I was like, well, this is kind of useless, because if I commit this and push it to the main branch, maybe I should have branched and made a new branch, whatever. I still don't think I've decided how I want to say it. But anyway, I probably should have done that, and maybe that way it would be okay. But pushing to master, in a state that did not render the 2D scene at all, because we had docking enabled, but no actual frame buffer setup, I thought that was a bit bad to do, so I quickly added that little bool in there. So because this is the actual view, right? This is what we have. We have this full screen Hazel engine kind of editor with this kind of panel that is dockable as long as it's actually part of this window, because you can also drag it outside of the window like this. If you do this, you can see it's actually a separate window over here. We have the settings window, and you can't dock this, I think, until it's if you grab it a certain way or whatever. It has to be in this view like it is now, and then you can dock it or whatever. I don't know, sometimes you can like that, so it's a bit weird. Anyway, this IMGUI docking stuff is fairly experimental as far as I know, so they haven't finished it. So hopefully everything will get better. So anyway, so we have this. We obviously have no scene. Our goal is, instead of rendering this texture, let's render the scene to a texture. So how do we do that? It's actually very simple. Frame buffers aren't particularly difficult to deal with in OpenGL. Basically, creating a nice API for them is probably harder than what this is. And in fact, I remember, maybe we'll do this next time. I did want to actually create a new project, being our kind of editor project, because this is currently in Sandbox and it shouldn't be. And for that reason, that's why I had to do these crazy hacks. But anyway, docking is going to be enabled, and hopefully we will have something on the screen today that is from our frame buffer. So the first thing we want to do is basically look at where we're doing all of our rendering, which is here. And what we want to do is, instead of rendering this scene and doing the clear, I guess, as well, and doing all of that stuff just like this, we want to first bind a frame buffer, do all of our stuff, and then just end the scene. And that's it. And if we have a actual texture attachment into that frame buffer, which acts as our color buffer, then obviously when our scene gets rendered and all of that stuff gets rasterized, it's going to go into that texture. And that texture is going to be what we're going to then display. This is very, very similar to the actual like swap chain and everything. It's just in OpenGL, you don't really control the swap chain. Something like Vulkan, you explicitly make basically frame buffers or textures for each kind of swap chain image you have. So in other words, if you're using like triple buffering, if you've got double buffering or triple buffering, you would have 2 or 3 actual textures, and you have to make that as part of the Vulkan swap chain. Not something that we have to do in OpenGL, is done for us. And so because of that, I actually think it makes this part maybe harder for some people, because they're like, well, what's going on? All that's going on is that, again, we're creating a texture, literally like any other texture. There's literally no difference in the simple case. There's no difference. There's just a regular texture. And then we're saying that, hey, render our scene to this texture instead of rendering our scene to the screen, basically. Even though behind the scenes, technically, of course, it gets rendered still onto an off-screen buffer and then swapped onto the screen. Now, the only other thing to take note of is the fact that a color buffer texture is usually not enough. We also usually want a depth buffer texture. Now, technically, we're rendering 2D stuff only, and my opinion of how to render 2D is pretty much don't use the depth buffer, even though we're doing that now. This is just for simplicity's sake, but usually if you're rendering 2D, you probably want to avoid using the depth buffer and simply render everything in reverse order. That way you'll always you won't get things like Z fighting, for example, because you're rendering stuff on the same axis, on the same Z value, because you're not supposed to have a Z value if it's, you're not supposed to have depth in a 2D scene. Otherwise it's not 2D, technically it's 3D. Anyway. Let's get on with it. I don't know if you guys like these kind of chats as much. I don't know. I feel like I've been like, between you and me, feeling a little bit insecure about this. But I just feel like I don't know if you guys want to necessarily hear that, or if you just want me to get to actually writing the code. Because obviously, like, we're still going to write all the code that we set out to write today. It's just that it might result in a longer video for you. And for that, I'm sorry if you're not into that. But if you are, then great, because I feel like talking sometimes. All right, anyway, so the first step really is to create, a frame buffer class. I'm not going to write any OpenGL code here to demonstrate how it works, because that's probably something for the OpenGL series. So once we're inside the renderer, I'm going to make a new file here called framebuffer.h, and we'll also make a framebuffer.cbp. And then under platform OpenGL, we're going to make a class called OpenGL FrameBuffer, because we're going to have an implementation for OpenGL. Now, a FrameBuffer itself can have a lot of, and I think some people are complaining about the text being too small, so I'll try and zoom in more. What was I saying? Yeah, FrameBuffers. So, the thing that, this is way too big. The thing that the thing with FrameBuffers, and I'm about to sneeze. Okay, I'm back from my sneeze break. The thing about FrameBuffers is that there's a lot of information that you might want to specify. So because the way that FrameBuffers work, especially if you spend any amount of time with them, you'll find is that and this is on core, this is in renderer. The way that they work is that, or rather their use cases and the things that you want them to be able to do is actually quite comprehensive, because frame buffers can be used for a lot of different things. You might be using a frame buffer like we are to simply render this scene. You might be using a frame buffer as part of like a post effects pipeline, but you also might be using a frame buffer as like a shadow map, or like some kind of like, what's a cool example? Oh, I don't know, like maybe like your character's walking around in grass and you want the grass to be trampled, and so you might be like, rendering basically the character's position onto like some mask, which is like part of a frame buffer, so that you can then do some cool stuff there to like offset vertex positions and stuff like that. Like you could use all of that stuff that I've just described uses frame buffers. And so in some cases, for a shadow map, for example, you might want a 2048 by 2048 frame buffer, and that's that. But for something like this, you want the frame buffer to be the size of your window. Maybe you're trying to save some performance, like if you're rendering on a phone or something like that, and you have like a 4K display on like an Android device. You can't render at 4K, so what you do is you render it like 1280 by 720 or 1920 by 1080, and then you upscale it at the end. So your scene has to get rendered to a frame buffer which has a texture that's like 1920 by 1080 or something like that, which is exactly half of the resolution of the phone. So that might be a factor of like 0.5 or something. So anyway, you might have a lot of different things at play there. And so you might not necessarily want to hard code a particular size, like 2048 by 2048 for a frame buffer. You might want it to be a percentage of the screen. And if the screen gets resized, like on a Windows computer, if you go full screen, or if you just drag the window and you just make the size bigger, then you will need to recreate those frame buffers. And so that is something that I call like a kind of dynamically resizable frame buffer. And then you might have something that isn't like that and that is fixed, like a 2048 shadow map. So my point is there are a lot of little things to think about when it comes to frame buffers, and that's why I'm going to introduce this new little thing that I like to do, which is creating a struct called frame buffer specification. And then this is actually a struct of properties. This is just something that I've started doing lately in my code. I don't really know where I got it from. I guess I came up with it. I'm sure a lot of people do this though. It's very useful. Instead of basically having a frame buffer constructor that could be very complicated and very long and might have things like, width, height, format, whether or not it's part of the swap chain, if it's multi-sampled or not, there's so many different things that you might want to, do you want to create a color buffer automatically? Do you want a depth buffer? Like there might be so much stuff to put into a frame buffer constructor that it gets overwhelming. So what I do instead, and in fact, we don't even have a constructor because technically we should be having like ref frame buffer create, because we actually need to create the correct instance. But the point is, what I like to do for classes like that is create this specification struct, and this can have anything. And the cool thing is it's not just that it can have anything, it can also have values for anything. So for example, I could have, width, and I could actually set it to something. Now this is a bit weird, like with width specifically as an example, and let me include base. With width, like it's weird to have a default width, I guess, potentially. Maybe the default width should be whatever the application width is. But, you can do stuff like this. You can have width height, we could have, for example, samples, and we could set that to 1 by default. That's done. That's the equivalent of just having like a default parameter that you set to 1 or something like that here. But the cool thing is we can do that. It doesn't have to be in a certain order, because with default parameters, you have to have them at the end, obviously, and they might clash with other overloads, and it's just a bit of a disaster. But with this, we can have it this way. We'll also probably need a format, frame buffer format maybe. We can set that to a default value. You guys kind of get the point. Like, I really like this approach, and then all we have to do is just pass in like a const reference of this into here. So a const frame buffer specification, just spec or something, right? And that's that. And then this can get stored as part of the frame buffer class. So inside OpenGL frame buffer, this extends frame buffer, and then we basically privately here, we just store the specification like that. And then usually what I mandate is that we basically have to have a virtual one of these, virtual frame buffer specification get specification const return, oops, sorry, this is pure virtual. And then usually, like, you don't have to, it depends on the class, but you can have a non-const version as well, just because sometimes it might help to actually, like, sometimes you might want to change the specification. It's just that if you do, then if you change it this way, then obviously nothing will be notified of the change. And if you change the width or height of a frame buffer, you'd probably want to rebuild that frame buffer. So that can be a little bit challenging, I guess. In this situation, you probably want something like set specification, or you'd manually have to call on specification changed or whatever, which is why we're going to leave it const for now, but just know that this is like an option, and for some classes it is quite useful as long as you actually call that code correctly. And obviously when you're designing an API, you want to make it as much as possible. You basically want to make it impossible to incorrectly use your API. So yeah, okay, anyway, let's pop over to the CPP file, include our PCH, include our frame buffer class, namespace Hazel, and I also want to implement this create function, and I also want to include Hazel platform. Is it not inside Hazel, just platform? Platform OpenGL. Frame buffer. And then obviously what we'll do is what we do in every other render API class, like vertex, like buffer or something. We do our little switch statement. So let's copy that, and then let's just say renderer get API. And that's inside the renderer. And then we'll return, obviously, an OpenGL frame buffer, and then we'll pass in that spec. Okay, that's that. So I think that looks pretty good to me. Again, with the format, we'll deal with that, and with specifically how we want to create color buffers and depth buffers and stuff like that might be something to deal with as well. But what I want to also do here is I want to float an idea, and that is we're going to actually have a bool, and I'll call this swap chain target. Now this sounds kind of fancy, but what this means, and this is just, again, a lot of this is inspired by Hazel Dev, because obviously I work on, for those of you who don't know, which is probably none of you at this rate, but I work on a version of Hazel in my spare time, so not in this series. It's called Hazel Dev. It's like the development like branch of Hazel, and that's got like, you know, the 3D and the level editor and all of that stuff that I'm getting sick of explaining every time I mention Hazel Dev. But obviously that code has that code base is a lot larger and more mature, because I've been using this stuff for like, I don't know, frame buffers have been in there for like probably over a year. So clearly I've added more stuff to them, I've refined them, and I've done all of that stuff. So a lot of stuff that I'm writing here is inspired. In fact, I mean, I've got Hazel Dev open on my other monitor here, and I'm probably going to be like just straight up copying some code from the Framebuffer class, because I'm not going to pretend that I have memorized the OpenGL API when it comes to making frame buffers. So a lot of the inspiration comes from that. And so something that we have there is something called swap chain target. Now, the reason is that at one point Hazel did work with Vulkan, because I just had a little fun weekend once where I was just like, let's jam in Vulkan. So I did that into like this 2D version of Hazel. And I guess we'll probably end up doing something similar. I don't know if we'll get around to it this year, but I'd like to, because we probably will, since we want to do Mac support, and then eventually Linux. Linux can run OpenGL fine. The Mac OpenGL story, which is not what this video is about, so I'm not going to take too long talking about this, but we basically want to use Metal on Mac, realistically. And then, so because of that, we'll probably end up doing Metal before we end up doing Vulkan. But again, it's not going to take as long as you guys probably think. Vulkan's going to take a while. But anyway, because it's supported Vulkan, there was like, I made this thing called swap chain target. This basically says that this frame buffer is supposed to be rendering to the swap chain. So in other words, this is the equivalent in OpenGL, as you'll find out soon if you don't already know. It's the same as saying GL bind frame buffer 0. It's basically saying unbind all of my frame buffers I want to render to the screen. So that's what this means. So what this allows you to do is it allows you to create a frame buffer that doesn't really exist. This is important a little bit later, because once we have frame buffers, we're going to be introducing something soon-ish called render passes. And a render pass is more of an abstract concept in OpenGL, but basically the way that I treat a render pass is something that has a frame buffer as a target, right? So in other words, if you want to render something, you say render a begin render pass, and then you pass in a render pass object, and that render pass object will contain a target for that render pass. At the very minimum, that's what a render pass is. It's just a frame buffer. And so that frame buffer can obviously be just the screen. If you want to render directly to the screen, then you have a frame buffer in that render pass that has a swap chain target of false. And a swap chain target of true. And what that means is that is not an off-screen buffer, that is the screen. So please render my render pass to the screen. And that's how you eventually get stuff onto the screen in something like OpenGL, where, you know, rendering to the screen means do not have a frame buffer at all. This is getting a little bit ahead of myself, but I just wanted to explain. This video is going to be an hour long. I just wanted to explain like a little bit of my thought process behind like why certain things are the way they are. It's because in the future, like I'm a little bit more aware of what's going to happen in the future than I guess what I maybe explain. Because if I explain everything like I am right now, it takes forever. So, but anyway, let's get on with this. So swap chain target, are we rendering to the screen or are we not? All right, so let's jump into OpenGL frame buffer. And then Obviously, you know, we construct this the same way we construct all of our classes. And like render passes are something that actually exist in Vulkan. So in Vulkan, there's actually like an object called like a render pass. So the same way that we have like GL frame buffer, like we have frame buffers in OpenGL, Vulkan also has render passes. So in like a render pass in Hazel would translate to an actual real render pass in Vulkan. But in OpenGL, if that's your API of choice, like if you're rendering using OpenGL in Hazel, then obviously it basically emulates that. But the thing is, it's not like emulating it is bad. In fact, I like the concept of render passes. I think they make a lot of sense. And they actually kind of help you organize your scene a little bit better, in my opinion. Okay, so in goes the const frame buffer specification. And then, you know, I don't really want to do a 180 on this entire code base, but the way that we've been setting this stuff up, some of the stuff I want to change. For example, bind, unbind. I'm not a big fan of this. It's something that it's something that I liked as part of the OpenGL series. I decided to include it in Hazel, but using it in Hazel Dev and stuff, like it's not bad, but I don't necessarily like this object-oriented approach all the time. So we might be making changes to that. So what I'm going to do is I'm actually not going to, well, I might have to because we don't have a renderer yet, but basically in the future, like I would not expect frame buffer to have bind unbind because a frame buffer should just be an object, which is essentially a set of data that the renderer then basically looks at and does what it needs to with that data. So in other words, like, you know, we're still going to have, you know, uint32t m renderer ID, or whatever. I think if we look at texture, yeah, so we're using uint32ts for that. Cool. Just because in Hazel Dev, I have an actual renderer ID type. So sometimes I just like to make sure that I'm doing the right thing. Anyway, let's write some more code. Let's create this stuff. Specification. Okay, so the idea is here we want to actually create the frame buffer. So we'll type in create, and the specification has been set. Now, the way that I like to write this is actually by having basically could be a public function even, called resize. And resize basically just it recreates it. I mean, you could call it invalidate, you can call it anything you want. Maybe we'll call it invalidate, because resize implies that it should take in a width and height, but we're actually reading it from the specification. So invalidate basically just says, and in Hazel Dev it's called resize. So again, like, you know, not necessarily consistent, but in this case I thought maybe invalidate would be a better word here. So invalidate says that the state is not valid, so recreate it, right? So what we want to do here is include glad, and we're going to write some OpenGL code finally. So this is going to basically say GL create frame buffer, or frame buffers. We're going to pass in that renderer ID. Straight away, we're going to delete frame buffers in the destructor because I always forget that. And then people with pull requests come in. So we'll bind the frame buffer. We might not need to bind it. It depends how we use it, I guess. Let me take a look at some Hazel Dev code. So the next step really is to create a color attachment. I mean, because that's what a frame buffer really is made out of. So usually what I do is create textures, and then we have like a color buffer attachment. So we'll say color attachment. Now the thing is, this should be completely dynamic and customizable. You shouldn't necessarily be doing this for every frame buffer because you might not need a frame buffer with a color attachment, or maybe you need a frame buffer with 4 color attachments, or maybe you want a frame buffer with a depth, maybe you want it without depth. So there's a lot of customizability when it comes to this. It's just that since we're kind of, you know, not trying to write a super cool, what's going on with this size? Oh, the target. It's going to be a texture 2D. Because we're not trying to create a super uber frame buffer class today, I think it's fine to do that. Now, I am binding a texture in Hazel Dev code, but I think I don't need to do that because the idea is what I want to do. There's two ways that this goes. You can either use, I think, texture storage, or you can use texture image. Now, these are actually different, and I think it's just probably text image 2D. I'm not 100% sure what the API is. Text image, though, since it takes in a target and not a type, it makes me think that it's a bit old. But ultimately, the difference between an image and a storage is that a storage, as far as I'm aware, is something that you can't later sample in a shader, because it's like just something that OpenGL might need internally. For example, a depth buffer is not typically something that you sample in a shader. And I just mean in our case, obviously in 3D graphics, sampling a depth buffer in a shader is extremely useful. But for what we're doing, for example, we've never had to do that yet. And so therefore, if we were adding a depth buffer attachment to this, we wouldn't necessarily need it to be available as an actual texture that we can bind and then sample from. So in that case, we could just use texture storage, because we need the storage for it, but we don't need the access. Image implies that it's something that you can actually, that you want to sample. So again, there's probably I don't know why it's not coming up, but there's maybe like, I thought GL texture image 2D exists, but it doesn't. But I don't know, I might be completely wrong here, because there is texture storage, but there's no texture image. So maybe texture storage is what you're supposed to use, but again, I'm not sure if that's sampleable. Whatever. Maybe someone in the comments knows more than me and would be nice enough to correct me. So the format. Okay, so we're gonna do RGBA 8. So what that means is just an RGBA, 8 bits per channel, kind of 8 bits per channel, right? So 1 byte per channel format here. This is something that is likely to change, because I imagine we'd probably be rendering, even though it is a 2D scene, rendering in HDR is nice, in which case we use GA, just float 32F, float 16F, or what is it? Oh, it's still RGBA 16F. I think float 16F is some other format. Maybe I'm thinking of something else. Anyway, RGBA 16F is what you would use for, or 32F is what you would use for like a floating point texture, essentially, something that is not in that 0 to 1 range and can be like high dynamic range, so that you can store color values greater than your normal kind of range, which is useful because then you can, map them into the appropriate space and do whatever you want with them later, because you have that extra information. But we're just going to stick with RGBA 8. This is something, we probably don't even need A here, but we'll keep it. This is something that is in the frame buffer format, but we're just going to get this up and running today, and then we'll probably flesh it out maybe next time, or my favorite thing to do, which is just flesh it out as we need it. So specification width, height, border of 0 format. This is the data format, so this will just be GL RGBA. Now unsigned byte is the type. And so we're basically making a normal texture. Now you could, again, abstract this out, and hopefully you guys can see that, but basically this is what I've written here. You can abstract this out and just, basically say, you could just create a texture using our texture API. I'm not 100% sure if I like that, because that means that you have to extend your texture API to play nicely with the frame buffer, which maybe you want all of your OpenGL code to make a frame buffer inside the frame buffer class and not abstract your code away into a million other files. That's something that can obviously add confusion and make everything a lot harder. So in that case, maybe don't abstract it out, but for now we'll leave this as, we'll try and have all of the code that we need all of the OpenGL code we need inside this file, so that it's a little bit more clear, at least for you people at this point. So texture parameters, I want to set the minification filter. So GL, what is it? Texture min filter. So this is obviously what happens. We'll set it to linear. This is what happens if we're downscaling our texture and upscaling our texture. This is the way that we want to interpolate those pixels. Linear is what we want here. And finally, we need to attach it. So GL frame buffer texture 2D. This just attaches the texture. So the target is GL frame buffer. GL color attachment 0 is what we're using here. So again, you can have a lot of different color attachments, like 10. Well, as in that was 10 that came up. Yeah, 10 is the maximum amount that No, it's not 30. So it's 32 different texture attachments is what the actual header file supports. The actual render capabilities obviously are up to your GPU drivers and everything like that. So text target is going to be texture 2D. And then what else do we have here? The texture, which is color attachment. And then the level, which I think is, yeah, just 0. The only thing we haven't done is we haven't bound this. Now, I don't know if there's a function. That's the problem with this new OpenGL stuff. There's so many different functions. And like a render buffer, again, is something different. Something that you... Maybe that's what I meant by texture storage and texture, because a render buffer, I think, is something you can't sample from. Anyway, I don't know. I have too many rendering APIs in my head, and I always have to look this stuff up. And obviously, this is very live, and I don't have a OpenGL reference in front of me. Okay, so anyway, let's bind the frame buffer as well. So we forgot to do that. Very important with frame buffers specifically that you unbind them, because you might not necessarily be binding them all the time. Like you might not be using them all the time. So in that sense, it's very important to make sure that you unbind them, because, and what am I doing? GL texture 2D. Because if you forget to, then maybe nothing will render onto the screen anymore because you accidentally have some random frame buffer bound. Okay, that's that. Now I will quickly also create a depth buffer. So to create a depth buffer, what do we need to do? Let's see. So we'll create a texture, and this will, well, I'm just using a texture 2D here. One, and this will be our depth attachment. And then we'll do bind texture. And we also need to support like multi-sampling and stuff like that here, which is, again, something for the future. Color attachment, and depth attachment. And yeah, these attachments will be dynamic, as I mentioned, in the future. So depth attachment, all this fun stuff. Let's do GL text storage. Oh, GL text image 2D. So, we can use GL text storage here. Target is texture 2D. Level 0 internal format GL depth 24 stencil 8. So we'll include a stencil buffer here. Width is the width and height, so specification width, specification height. Now, I'm not sure because, well, this is what I wrote now, but in Hazel Dev, it says I'm actually still doing a text image. I've written text image 2D, GL texture 2D, 0 depth stencil 8. We have a lot of stuff here, actually. I'm not even sure what this code is. Width height 0, GL depth stencil, unsigned int 24.8, which is just referring to the first 24 bits being for the depth buffer, and then the next 8 bits being for the stencil buffer, and then null. So I don't know. This is what Hazel Dev has. So clearly this works, but I'm going to try text storage 2D because, again, we don't... The way that we're making this is just for OpenGL's use. And then finally, we just do frame buffer texture 2D, frame buffer, and depth stencil attachment. We could have made it without the stencil buffer, but in this case, we'll include it. Depth attachment 0. All right, that's it. So the last thing that you should do, definitely, is you should basically just check the frame buffer status. So this just basically checks to make sure that, you know, everything's working. So if the frame buffer status, right, if it's equal to frame buffer complete, then the frame buffer is complete and you've done everything correctly. So let's wrap that into an assert. And then, you know, we'll say frame buffer is incomplete. So this was basically just a little check to make sure that our frame buffer is A++. All right, that's it. Finally, what I'll do is I will what are we at here? Oh, what a long episode. Void bind, void unbind. So these, we are going to have this for now just because our API kind of needs to have them. We also need to have this. So let me just, but this is like, I probably would remove these in the future just because you shouldn't really be taking a frame buffer object and then calling bind on it. That's very much out of context, and that's why I don't like that. Because what is binding a frame buffer just out in the open? Like, what does that actually mean? It doesn't do anything. It needs to be part of a render pipeline, you know? It needs to be part of like a literal renderer. So that's why I like to leave that stuff up to the renderer. Anyway, so we have these now. Let's implement them. Get specification is something that we'll just do here. So override return spec. Okay, so bind obviously just calls this. And unbind just calls this. And I don't really like to call bind here because, I don't know, I think that's a bit weird, or here rather. This should just be the OpenGL code, like that's fine. Okay, and also because we might not even need to bind them, because if there are functions in your OpenGL where you don't need to use the whole state machine thing, then we'd obviously use them. Okay, that's that. I don't know if this is gonna work. The last thing we actually need though, at least right now, is we want to be able to get a color attachment out of this. So for now, I'll just add a UN32T here called get color attachment renderer ID. So what this is going to do is just return the color attachment. So this is just so that we can bind it as a texture, because the idea is we should just give that to ImGUI. So this now becomes, no, that's fine, I think. Yep. Okay, so basically, if I've done this right, which is very questionable, but if I have done this right, then we just go over here, we include frame buffer. In Hazel, then over here, we can just say Hazel ref Hazel frame buffer. Then we do frame buffer. Okay, so this is how the whole spec system works. So we do Hazel frame buffer specification FB spec, and then you can call it something actually good, not FB spec, but we'll set the width to be, well, this should be the size of our window, which I think is 1280 by 720. Where do we even set that? Window create just takes in, I think it just has some default parameters here, 1280, 720. So just for now, you know, we'll talk about this more later, but we'll set it to 1280 by 720. What else do we need? I think everything else is, yeah, samples is set to 1, and we're not even using that, and swap check time is false, and we're not using that. So now we can create the frame buffer. So this is Hazel frame buffer create. We pass in the spec. So that's kind of how, that's what the code ends up looking like. Unless you have like either a constructor here, or you have like some kind of other things that you can set up. Usually it's, or you can obviously also set it to like an initialize list, like any other struct or class really in C++. Now what we need to do is when we render stuff, before we set the clear color and do all that stuff, let's do a quick little renderer prep. We'll do a frame buffer bind, and then we'll do an unbind. And that's it. So now we should be rendering our scene to a frame buffer. What we should then do is decide to draw that on in ImGUI. So the way that we currently were drawing this was we were doing the checkerboard texture render ID. Let's do something a bit different. Let's do frame buffer get renderer, get a color attachment render ID. So now we're getting the color buffer from that frame buffer, which is where everything should have been rendered to. And we're drawing it. Let's not draw it as a square because it's going to look bad. Let's do like, well, it's 16:9. So if we do 320 by 180, that'll be 16:9, and maybe that'll look nice. Let's just, you know, let's see if this works, because I'm very doubtful. I've probably messed a lot of things up. as usual. Yep. Okay, so what are we looking at here? We have a frame. Okay, so the frame buffer is not complete. Do we have any other OpenGL exceptions? Okay, levels, width, and height must be 1 or greater. Okay, so something's weird here. Invalid value generated. That's clearly a fatal. That's another thing that I'm not very happy about. In our error, so that clearly happened from somewhere here, and it looks like something may have been wrong with our what's this border? No, there might have been a place where I accidentally set levels to 0. Levels. So this should be 1, I believe. That's probably it. But we should also maybe not. No, it's just not happy about the frame buffer being. Okay, let's switch to the Hazel dev code just to see if that's the issue. Because obviously this code I have actually tested and it is working. So let's make sure that that's not the reason, and it doesn't look like it is. What a header. Okay, frame buffer incomplete. What did I do? You guys are probably laughing at me. Well, for one, I mean, I didn't bind the texture. Because I think the reason I didn't automatically bind it, by the way, is because I was hoping I wouldn't need to, because if you use, like, there are some, I don't know, I didn't need to get caught up on this, but there are some, like, OpenGL commands that have stopped taking in this stupid thing here and started taking in the actual ID. And they're kind of like named buffers and, you know, other things. I don't know if there's a named texture. There's named frame buffer texture, named buffer data. Anyway, I'm kind of using a mix of the old and new API, which is why, you know, in this case I am binding it, which is great, but I think I wasn't binding the color attachment, and that may have been the reason. Yeah, it was the reason. Okay, so now you can see that what we have is we have the screen here. That's what we're rendering, except now it's like a little texture that we can see anywhere. Let's quickly go back to the texture storage, because that should work as far as I'm aware. The real problem was me not binding the texture. Yeah, okay, great. So there you go. So now obviously what we want to do is, instead of making it tiny like this, well, for one, let's make it 1280 by 720 maybe. Because that is slightly small. So we'll do 1280, 720 here. And that will be at least a little bit bigger, and obviously it'll just be the size of, oh, okay, it's still tiny. Why is that? Why is the image so small? Isn't that the image size? 1280 by 720? That's a bit weird. Maybe that's, yeah, that is odd. I don't know why the image is so small. Oh well. I guess that's the way that it is. Yeah, everything else looks good to me. Maybe there's some other size that's controlling it, or maybe maybe I'm just a buffoon. It's probably the latter, because I'm editing the wrong code path, because I forgot I had to. Because that, by the way, is something that I made for off camera for another episode, sorry, for the to make sure that you could render the scene last time, because that's the way it worked. Because obviously we removed any kind of, by enabling docking, we removed the screen buffer being rendered, as I mentioned, and I wanted it to be rendered, so I just copied the code and made 2 code paths. I don't know why that was so hard to explain. Anyway, yeah, so there we go. Here's our, you know, here's our little frame buffer. You can see that we're rendering it, and we're displaying it as just an IMGUI image. So this is basically like step 1. Right, the next step, and what we'll do next time, is we basically want to take this and actually make a proper IMGUI panel out of it. And then, oh, and obviously key events are still here. They're actually active, not in this window. So if you click here and press WSD, it doesn't work, but in this window. And there's some things you can do, obviously, to fix that. But ultimately, my point is everything still works, and you should be able to, you know, do everything like normal. But minimizing the windows also pauses it, because that's what we do. I think if our main window is minimized, if it's minimized, we stop updating everything, and obviously minimized is the main window, not the window with the scene. So there's a few things you need to do if you want to support this specifically, which is having multiple windows. But if it's all in here, then obviously everything works as expected, and you'll never be able to do anything bad. So yeah, so next time what we want to do is basically take the, let's fade to the full camera view. What we want to do next time is take what we've done here and actually make an IMGUI panel out of it so that, you know, we have the viewport panel basically. And then we can set the frame buffer size to be whatever the size of the panel is. So we take the panel size from IMGUI, make that our texture and frame buffer size, and then use that. Hope you guys enjoyed this video. If you did, please hit the like button. Don't forget that you can help support the series on patreon.com/the Cherno. Huge thank you to everyone who does. That is the reason why we are here today. So huge thank you to everyone. I really appreciate it. Looking forward to next episode. I'll probably release it this week because I'm having a lot of fun with this and I obviously want to hurry up with this. So thank you all for watching. I'll see you next time. Goodbye.